Hello, this is about resolving a vector. To resolve a vector, we need to replace it with an equivalent set of components. Normally we choose, so let's just write equivalent set of components. So that's what we'll do when we resolve a vector. We need to choose one of them to be at, or both of them to be at right angles to each other. They should be chosen to be right angles to each other, and only two. We only choose two components. So these are the key things you must consider when you're resolving a vector. Be aware that it's replacing a vector with two components. They must be at right angles to each other, and only choose two components. Now, very important is that we draw a sketch. And this is what our sketch looks like. So we have that the slope inclined at 30 degrees. And we have a weight of 10 newtons. So we'll let this represents the weight. And we have its weight acting down here at, let's put it along here, 10 newtons. And we can just have our triangle outline there. Now, if we resolve parallel to the slope, we have that the magnitude of that force is 10 newtons sine 30 degrees, which is 5 newtons. So this is a hypotenuse, and if we resolve it parallel to the slope, that will be going down the slope, then we'll take the opposite over hypotenuse, which is sine, so it's 10 sine 30, which is 5 newtons. Now if we resolve perpendicular to the slope, so perpendicular to the slope, then we're taking cosine, so we're taking the hypotenuse with this side of the right angle triangle. So we have 10 cosine 30 degrees, and it's equal to 5 root 3 newtons. If you're confused by this, you can write it in terms of the ratio, the trig ratio, cosine 30 degrees is equal to the adjacent over hypotenuse. And if you were to rearrange this, we'll have 5 root 3 over 10. Okay. So Another question, oh, I didn't put the angle here. Another question, if you might have been wondering, why is this 30 degrees here, is we have similar triangles here. Once we use this common slope here and we have a vertical, the weight acting downwards vertically, then, sorry, as the hypotenuse, sorry, and we have a vertical acting downwards from the slope, we have a similar triangle to what we have here on the large scale. So this angle is also 30 degrees. If you look at the definition of similar triangles, they have equiangular, the conditions are they're equiangular. And so in this case, we have this as being 30 degrees, this is 90, and this must be 60. So that's why we use 30 degrees to calculate our magnitude parallel to the slope and magnitude perpendicular to the slope. Thanks for watching. I'm Alistair.